All right, today we're going to go over 3.4 homework, part 1, page 194 to 195, 1, 2 to 30, even. Now, before we get started with 3.4, there are some key ideas we talked about in class. So in case you weren't here or you can't remember, you have to know these two main ideas. So the first thing is, if you see one equation, that means more than likely you're going to be finding an inverse. Another way to know if you're telling you to find an inverse, if the directions say find the inverse. So find is the key word. All right. Now, step 1 with that says you're going to switch x and y. Now remember, if you see f of x, you're just going to rewrite that as y to start. Like in 22, you're going to write y instead of f of x first before you switch x and y. Number 2 is you're going to solve for y using PEMDAS backwards. So you're going to go PEMDAS backwards, get y all by itself. And the last thing you're going to do is you're going to write f negative 1 of x instead of y. So f negative 1 of x, that's like the notation we use. The book doesn't really say to use it. I like using that notation because it says f inverse of x. And that's the key, is you're making an inverse function. So this last step right here tells you, hey, I know it's an inverse. All right, that's why I make you write it. Now the other thing you're going to see is you might see the word verify. All right, if you see verify, that means more than likely you're going to have two equations. And that's when you're going to say, okay, I know there's two sides to every story. So what I need to show is I need to show f of g of x and g of f of x. That and is important. It has to be and. They both have to be true. Now remember, this is a proof. You're going to show all the steps because it's a proof. All right, and then remember your closing arguments at the end. Okay, so that's it. That's really the two big ideas. If you can remember that much, you should pretty much do this section pretty easily. All right. Now, number 1 says, state the definition of an inverse relation. Well, an inverse relation, all right, so an inverse relation it is something that interchanges the input and output values of the original relation. Now, a lot of times we're going to talk about functions. So, like for right now, you can think of an inverse function interchanges the input and output values of the original function, because we're going to be focusing a lot on functions. Okay, so that's pretty much it. All right, number 2 is you say, explain how to determine if a function g is an inverse of f. So really the best way to do that is you're going to create a proof showing that f of g of x equals x, not equals to x, equals x, and g of f of x equals x. All right, that's going to be the idea. So remember, it has to be a proof. Okay, and that's it. All righty, so number 4, we have one function. We're going to find the inverse. So step 1 says to switch x and y. So all I do is I write x equals minus 2y plus 5. Step 2, solve for y. Now remember, you're going to use PEMDAS backwards. So I look for any subtraction. I don't see any subtraction. I see some addition. That's why I have minus 5 from both sides first. So I have x minus 5. Somebody's going to put minus 5x. Somebody's going to put those two together. You cannot do that because they are not like terms. All right, addition's gone. There is no division, but there's multiplication. That's why I divide by negative 2, divide by negative 2. So I end up with y, because I like to write my y on the left. You don't have to do that. Equals x minus 5 all over negative 2. Step 3 says you're going to write f inverse of x. It's f with a little negative 1 of x for y. So your final answer is you're going to say f negative 1 of x equals x minus 5 all over negative 2. If you want, you could write negative 1/2 x plus 5/2. That's an option as well if you take the 2 to both those ones. But you don't have to. You would have to break it up if it was a fraction over a fraction. You don't have to do it in this one. All right? That's it for number 4. All right, number 6. Y is equal to 10x minus 28. So step 1 means I'm going to switch x and y. So I write x equals 10y minus 28. Step 2 says I'm going to solve for y, which means I'm going to use PEMDAS backwards. I see subtraction. That's why I plus 28 to both sides first. Now somebody's going to put 28x here, but those cannot be combined because they are not like terms. So I have x plus 28 equals 10y. So subtraction is taken care of. There's no addition. There's no division. Oh, look, there's multiplication. That's why I have to divide by 10. So finally, I have y equals x plus 28 all over 10. So step 3 says you're going to write f negative 1 of x for y. So my final answer should be f negative 1 of x equals x plus 28 all over 10. Or you could say 1/10 x plus 28 over 10 becomes 14 over 5. That's if you want to put it in slope-intercept form. All right? I think that first one's the easiest. And that's it for 6. All right, 8. Step 1, I'm going to switch x and y. All right, that's 1. Step 2 means I'm going to solve for y, so in case you need to see PEMDAS backwards, I see subtraction. That's why I add 5 to both sides first. There's no more addition. There's no division. I see multiplication. That's why I divide by negative 18. So I end up with y equals x plus 5 all over negative 18. So my final answer remember, this is all step 2. All this. Step 3 says I'm going to write f negative 1 of x equals x plus 5 all over negative 18. You could write negative 1 over 18 x plus 5 over negative 18 if you want in slope-intercept form. But either way, that's okay. So that's your final answer. And that's it for 8. Alrighty. 18, step 1, says I'm going to switch x and y. Now, step 2 says I'm going to use PEMDAS backwards. So that's why there is no subtraction. That's why I get rid of the addition first by subtracting 2 from both sides. Remember, x and minus 2 are not the same, so I have x minus 2 equals minus 2/3 y. Now I'm going to get rid of division. That's why I'm going to multiply by 3 to start, because that divide by 3 is a fraction. Alright, those will cancel. So I get 3x minus 6 equals negative 2y. Now I'm going to get rid of the multiplication. That's why I divide by negative 2. So I end up with y equals 3x minus 6 all over negative 2. So my final answer becomes f negative 1 of x equals 3x minus 6 all over negative 2. Or I could split this negative 2 up and it goes to both, where it'd be negative 3/2 x plus 3. Either one of those correct answers. Just make sure you have this f negative 1 of x. All right. Now I'm going to show what happens sometimes on this one when you do not split up the multiplication and division. So hold on one second. So sometimes people get here, minus 2, minus 2. And they try to divide by a fraction because they want those to cancel. And they do this, so they get here. And they try to say their final answer is y equals x minus 2 over 2/3 negatives. But you cannot have fraction over fraction. So that's why I did it the way I did it in the last part. But if you don't want to do this, you could put x is negative 2/3 at y plus 2. Subtract 2 from both sides. You get x minus 2 equals negative 2/3 y. You could multiply. So dividing by a fraction is the same as multiplying by a reciprocal. So I could multiply by negative 3/2, which makes those cancel, which means I do that on both sides. So I get negative 3/2 x plus 3 equals y, which is what I had as my final answer. So that's another way to get that in number 10. So that's just another option for 10. All right, so number 12, they made a mistake. So I'm just going to do number 12 just like I'm not even looking at the original problem. So I still switch x and y. I do PEMDAS backwards, so I add 11 to both sides. Divide by 6. I end up with y equals x plus 11 all over 6. So remember, you have to rewrite your final answer as f negative 1 of x equals x plus 11 all over 6, or you could make it 1/6 x plus 11/6. Now if you write it this way, you see that they forgot to divide everything by 6, and they forgot f negative 1 of x, or f inverse of x. So they forgot two things. All right, and that's it for 12. All right, so 14 says, write a function f such that the graph of the inverse function, so that's inverse function, is a line with slope 3. So the first thing I have to know is I have to know slope-intercept form. So I have to have mx plus b, because that is slope-intercept form, because remember, it tells you the slope and the intercept in that order. So you have to know that. The other thing you have to know is you have to know that the inverse of the inverse is the original. All right? So if I know that f negative 1 of x has a slope of 3, all right? If I know f of x, f inverse of x has a slope of 3, all right? Then I can make a function like this. Let's just say I'm going to put in 9 here. All right? I just made this up. This was my choice. Because that's b. I get to pick b. All right? I just made up an inverse function. So the inverse of this is the original function. So I just follow my 3 steps. So I'm going to follow my 3 steps. So I write y is equal to 3x plus 9. I switch x and y, so I get x is equal to 3y plus 9. I subtract 9 from both sides. I get x minus 9 equals 3y. I divide by 3, divide by 3. Now remember, I have to have it in slope-intercept form, so I cannot leave it like this. So I need it in slope-intercept form. So that is not slope-intercept form. So I have to take that 3 to both of them. So my final answer is f negative 1, or I'm sorry, not f negative 1 of x, it's f of x, because we started with f negative 1 of x, is x over 3, or 1/3 x, minus 9 over 3 is minus 3. So that's my new function. Now, if you were late on this, I'm going to be checking this one for accuracy. You cannot use 9, all right? That's the only rule. You can't have to use something else besides 9. All right? Thank you. All right. Number 16 says verify. So since it says verify, remember we have to start off with f of g of x, and I put a question mark because I don't know if this is true. I want to see if that is equal to x. So what I do is I say f of big old blank space, and that looks like this one. So if I have this on the left side, I'm going to write this on right there. But instead of x, since I have an x there, I don't have anything there. So I put 2 big old blank space plus 3. Now, it actually says g of x there, so I put g of x here. Which means I take all this and I plug it in right there. So I put 1/2 x. So I'm going to rewrite this to make it bigger. One half x minus 3/2. Now I'm going to simplify. So I simplify that. I end up with f of g of x. Now remember, I keep this because that's my label. I get x minus 3 plus 3. Those cancel. So I end up with f of g of x equals x. I'm good to go. Now remember, there's 2 sides to every story. So now I have to prove that g of f of x equals x. I don't know that yet. So I put g, big old blank space, and then I write 1/2, big blank space. Now remember, this is where I put in 2x plus 3, because it's not big old blank space, it's f of x. I distribute the 1/2, so I get g of f of x equals x plus 3/2 minus 3/2. Those cancel, so I just proved g of f of x equals x. So since f of g of x equals x and g of f of x, they are inverses. And that's it for 16. So a lot of work to prove this, but you got to show all these steps. You have to show your work. Okay? And that's it for 16. Now remember, if you're lost on 18, you just have to look on the steps to verify. See how it says verify here? We're going to follow all this stuff. So I'm going to show the 2 sides of every story. I'm going to show f of g of x equals x and g of f of x equals x. So the first thing I have to show is does f of g of x equal x? I'm not sure. That's why I put a question mark there. I don't know yet. So I put f, big old blank space. So I start with f, and I'm going to put this on the other side. 1/5, big blank space, minus 1. Now really, it's g of x in there. So I take this, and I plug it in right there. So I put 5x plus 5. I distribute the 1/2. So I get f of g of x. Remember, I put this label every time because that's my label. It's like we were pretending we're in court. All your evidence has to be labeled. Everything's got to look nice. So I get x plus 1 minus 1. Those cancel. So f of g of x does indeed equal x. Good. But I'm not done yet. I'm only halfway there. So I have to try and prove g of f of x equals, so I put a question mark because I don't know if it's true, equals x. So this time I have to start with g of big old blank space. So I put 5 big old blank space plus 5. Now remember, it's f of x there, so I put this right in there. 1/5 x minus 1, distribute the 5, so I get, remember there's my label, g of f of x equals x minus 5 plus 5. The 5's cancel, so g of f of x does indeed equal x. My last thing is my closing argument, so I have to say, since f of g of x equals x and g of f of x equals x, they are inverses. And that's it. Alright, 20 is the same way. So the first thing I have to do is I have to say f of g of x, and I gotta hope that equals x. I don't know if that's true. Alright? So the first thing I'm gonna do is I'm gonna put in f, big blank space. So I'm gonna put 5x squared minus 2. And then remember it is g of x, so I put g of x in there. So I put right next to it x plus 2 all over 5 to the 1/2. Okay? Now, I'm going to take the 1/2 to the top and the bottom. So I get f of g of x equals 5x squared minus 2 times x plus 2 to the 1/2 all over 5 to the 1/2. And really, since there is nothing that can be combined, I just put these two together. And I'm done. So, the biggest issue is I could not get f of g of x, since I can't do any more work, does not equal x. So my last answer is I say since f of g of x does not equal x, they are not inverses. And that's it. So if they are not inverses, it actually makes it really easy. I don't have to do all the work. I don't have to do g of f of x because it doesn't matter. It doesn't matter now because that right there. If one's not true, if one's not true, it doesn't matter if the other way is true. So that's it. All right, number 22 says f of x equals x to the 7. So remember, since there's one equation and the directions say find, you're going to use your 3 steps. The first thing you got to do is you have to write y instead of f of x. So I say y is equal to x to the 7th. Now I switch x and y. Now I use my PEMDAS backwards. There's no subtraction, no addition, no division, no multiplication. There's an exponent. How do I get rid of an exponent? Use a check mark. Now the thing is, you have to use the little 7 here, because if not, they don't cancel. So that's why I get y equals, because that turned into there, the 7th root of x. Last step is you say f negative 1 of x equals the 7th root of x. And that's it for 22. Alright, so 24 says f of x equals negative 10x to the 6th. So for right now, you're going to ignore this. So don't worry about that right now. We'll talk about that tomorrow, about what that means. And at the end of this problem, I'll quickly talk about what it means. Alright, but since we see one equation, so one equation means you're going to follow your 3 steps. So I'm going to write y equals minus 10x to the 6th, because I don't want f of x. And then I'm going to use PEMDAS backwards for step 2. I don't see any subtraction, no addition, no division, multiplication. That's why I have to divide by, alright, negative 10 to start. So I end up with y over negative 10 equals x to the 6th. So I put the 6th root on both sides, because that makes the little 6's go away. So I get the 6th root of y over negative 10 equals x. So my final answer is f negative 1 of x equals the 6th root of y over negative 10. All right? Now, what we're going to talk about is this tomorrow. This right here tells me that I need to use x's that are less than 0, so I'm going to make that a negative. All right? So that tells me to pick negative. But we'll talk about that more tomorrow. All right? That's it for 24. All right, 26. So I'm going to write y is equal to negative 2 fifths x to the third. I'm going to switch x and y, so I have x equals negative 2 fifths y to the third. I'm going to use PEMDAS backwards. All right, you can either, if you want to divide by negative 2 fifths, you can, but that's going to be a fraction over a fraction, so I'm not going to do that. So remember, dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to multiply both sides by negative 5/2 because I have to get rid of multiplication and division before I get rid of my exponent. So I end up with negative 5/2 x equals y cubed. Now I'm allowed to take the cube root of both sides. That's why there's a little 3 there. All right. So I end up with y equals the cube root of negative 5/2 x. The book leaves it just like that. I'm okay with that. If you want to take the negative out right away, you can. There's a bunch of, you could simplify the radical if you really, really wanted to, but the book leaves it like that, so I'll take it like this. So the last thing you're going to do is you're going to say f negative 1, or f inverse of x, equals the cube root of negative 5x all over 2. And that's it for 26. All right, so what is the inverse of negative 1 over 64, x to the third? So I'm going to say f of x equals negative 1 over 64, x to the third. So the first thing I'm going to do is I'm going to write y equals negative 1 over 64, x to the third. Then I'm going to rewrite, I'm going to switch x and y. Now, I'm going to multiply both sides by the reciprocal. That's why I multiply by negative 64. So I end up with negative 64x equals y cubed. So I have to get rid of the cube root on both sides. So I get y equals the cube root of negative 64x. Now remember, negative 64 is perfect. Is a perfect cube. So this negative 64 gets to leave because remember you can rewrite it as y equals the cube root of negative 4 cubed x. So he gets to leave. So y equals negative 4 cube root of x. Now finally, I'm going to rewrite this as f negative 1, or f inverse of x equals negative 4 cube root of x, which the closest one to that is c. All right, and that's it. All right, that's it. All right, 30 says to graph a function. This one's just a line, so it's really easy to graph. So I'm going to plug in negative 1. Negative 1, the opposite of that is positive 1 minus 5 is negative 4. 0 is negative 5. 1 is negative 6. So I put negative, let's just make this. That's our middle of our XY chart. So there's X, there's Y. So I'm going to go 1, 2, 3, 4. We'll make these 2, 2, 4, 6, and 8. Negative, 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 negative. So I got 0, negative 5. 1, negative 6. And there's our line. And to finish out the rest of it, you just have to do the horizontal line test. So if you look up the horizontal line test, and you are be able to answer that question about the inverse. And that's it.